Hi everyone, I'm Aditi Pandit and I'm an engineer at IBM Ahana, and I'm going to talk today about Prestissimo, Presto's next-gen query execution engine. In this talk, I'll first give an introduction to Presto. The bulk of the talk will be about Prestissimo, the motivation and the architecture, and towards the end, I'll talk about the status of the project, roadmap, and community. Introduction to Presto. Presto is an open source SQL query engine. It is a project that started at Meta and has been heavily adopted by several big data companies, most notably Uber and Bytedance. To give a sense of the scale that we're talking about here, we're looking at like a lakehouse of 300 petabytes at Meta, at Uber, like 100 million queries a day, and Bytedance has a cluster of 10K plus compute cores. So this is a very well battle-tested open source SQL query engine out there, and it has a very vibrant open source community. It's a Linux Foundation project, and here are many of the logos of the users and the contributors. So about Prestissimo, Presto has been around for over a decade, and in recent years there was a lot of thinking around at Meta around like new warehouse architectures, and in the industry generally around the lakehouse architecture. And what we want to achieve is for Presto to be like the best of breed open source query engine for the data lakehouse out there. And in terms of thinking about like what could be the projects that really give us a huge leapfrog benefit, right? One of the things that sort of came up was a whole redesign of the Presto query eval in C++ using vectorization and SIMD related ideas. New world. So there are similar initiatives going on in the industry, most notably Photon at Databricks. Trino also is doing Project Hummingbird. And so there are many like common themes between these projects. There's similarities and there are differences, but that's a general idea. So what is Prestissimo? So Prestissimo is a full rewrite of the Presto query eval, which was originally in Java in C++. So this thing is called the Presto worker. And Prestissimo is built on the Velox library. Velox is another open source project out of Meta, and it's a library of data processing primitives based on ideas around vectorized execution, SIMD, smart prefetching, runtime optimizations. It also has a full homegrown memory management system with very sophisticated accounting and features like memory arbitration. So, memory arbitration is a feature to pause execution in one part of the query and reclaim memory from it and transfer that memory over to another operator in the same query or another query. Velox has all these sophisticated features. It is a generic data processing library used across multiple data engines. Prestissimo, there's another industry project around using it for Spark, and it's also used in multiple streaming and machine learning engines within Meta. So in terms of the Prestissimo architecture, if you look at Presto clusters, right, this is what they look like. There's a coordinator and there are multiple workers. The coordinator is the front end. It receives the SQL query. The SQL is parsed and optimized into an execution plan, which the scheduler schedules on the workers. The workers are the main workhorse in the system. They actually do the data reading from the underlying object store file systems like S3 or HDFS. The data could be in org parquet files and other formats. So the worker receives task requests, and those tasks comprise of fragment plans, which could involve table scans that are reading, doing like different query processing, and the results are could be given to subsequent stages on other workers or then returned back to the coordinator. What's kind of important to note here is that there is a certain control API around like setting up these tasks, scheduling them on the workers, getting their status and info as the tasks keep running. There's also a data exchange protocol around like the format of the data being transferred across the workers or between the coordinator. What we did for Prestissimo is keep those parts of the system exactly the same, but flip the actual worker with a new runtime. So if you see the Prestissimo architecture, the cluster looks very similar to the Presto clusters, except for the worker piece, which is now a C++ executable instead of the old Java runtime. And that executable internally uses Velox. So there's a Velox Hive connector and a Velox data engine that do the actual data processing. So what does all this buy us? Firstly, like a huge performance boost. Um, we see a much better price performance, and what that means is that the same query workload can be executed on much smaller clusters. Um, and in actual like production deployments at Meta and Bytedance, we've seen improvements where like the same query workload can be executed with a cluster with just like half the nodes, sometimes even going down to one third the number of nodes. The operational characteristics are much smoother. There's no Java JVM garbage collection. The memory management SIMD are under explicit control in C++. Engineers understand the performance of the system much better. And since we use Velox, which is like reusable and extensible primitives across all these engines, there's a big number of engineers who now understand how to build and operate these systems. So again, like quickly recapping the Prestissimo processing with an example. So you have a SQL query that hits the coordinator. I've taken a modified TPC-H Q1 SQL where we are scanning the line item, computing some aggregates over it, and then sorting the results and returning to the user. So this query gets transformed to the logical plan on the right-hand side with a scan filter project with a hashtag followed by a sort. The coordinator transforms this into an execution plan, which comprises of multiple stages, similar to the logical plan. So it has a scan filter project with a partial lag, final lag, followed by sorting operators to the output. And these stages are what are going to be executed on the workers in a distributed way. So the workers actually receive the plan fragments comprising of those individual plan nodes and operators. Prestissimo kind of takes that plan fragment and converts that Presto plan fragment into a Velox plan. Prestissimo sets up the thread pool IO executors, exchanges, and hands the plan over to the Velox driver for execution. So at the Velox level, you have a plan node spec, which is a spec of the query processing to be done. But the actual query processing, the data movement is done by operators. So if you kind of zoom in, your query plan got transformed into the stages, which map to tasks done on the workers. And each task kind of zooms in to like these operator pipelines. So basically, you took your plan fragment and it transforms into operator pipelines, multiple of which can be doing the same query execution. And these are what actually drive the data movement and the data processing in Prestissimo. So in terms of the project status, where we are today, we've been doing this project for over 3 years now, and we have got very extensive SQL coverage. We are at a point where we do like queries to the complexity of those in the TPC-H, TPC-DS benchmarks, which are fancy queries, including like window functions and group by grouping sets at a 10K scale. So that's like 10 terabytes. We support writes. CTAS is supported. In terms of the file system support, we support S3, HDFS, GCS object stores. There is a highly performant Parquet reader writer. Dwarf, which is a format very similar to WRC, is also supported by Prestissimo. In terms of the future roadmap, we are looking to enhance the client SPI for Prestissimo so that we can leverage the connector ecosystem. Lakehouse features, most notably Iceberg, are in development. And in addition to that, we are constantly running like production deployments, bombarding clusters, Prestissimo clusters with SQL queries and looking for stability kind of fixes in the system. We are a very vibrant community. I've added links here for the working groups, GitHub, Slack, Meetup. Please do take a look at the material here and feel free to reach out to any of us for any questions about using Prestissimo or contributing to Prestissimo. And all contributions are welcome. I will conclude thanking the Presto and Velox teams at Meta and the collaboration with IBM, Intel, ByteDance to make this project happen. Thank you.